Today we're going to be monitoring a stream that is surrounded by commercial parking lots, which are heavy hitters for road salt use. So this stream sees a lot of really high spikes in chloride through the winter and spring. So we'll be taking a look at that today, and I'm going to grab my supplies so we can head down to the stream. So of course I always have a bucket to help carry everything. I've got my lab notebook, a labeled sample vial, syringe and a filter, and my conductivity meter to take a field snapshot of temperature and conductivity of the water. Always want to bring some waterproof gloves when you're sampling in the winter. Something that we're not going to use right now, but I use a lot at other streams if I'm sampling off of a bridge, is a Van Dorn. So these plungers attach up at the top here. And when you're sampling off a bridge, it's got a nice long rope so you can lower it down into the water and take this weight when it's down in the water and you're ready to collect the water. Snaps, pull it back up, and that is how you get your sample from, a stream that's not super shallow. Today we're going to be looking at Pheasant Branch South Fork, which is really shallow stream, so I'm able to just step down into the stream and use the syringe to sample directly. All right, we are ready to head down. The first time I went out sampling, I did not write everything down because I was like, I think I know what I need. And I got out drove out, to where I needed to be, and I did not have everything that I needed. And I had to drive all the way back to the lab to load up everything else. So now I always make a list. Like, even if I'm doing this every week, I have a big master list that I look at and I'm like, all right, what do I need tomorrow to bring out to the field? It really sucks when you have to drive all the way back to the lab when you're out here ready to take a sample. So I wear rubber gloves over my little glove liners for two reasons. One, so I don't contaminate the water sample. And the second reason is it just keeps my hands nice and warm and waterproof. Oh, there you are. This is a conductivity logger that measures the stream conductivity every 30 minutes. And I leave it out here and I try to collect it maybe once a month to see what we've got going on. It's really useful because I only come out about once a week to take water samples and to take measurements directly from the stream. So this gives us a lot of information about what's going on in between those weeks. Conductivity measures the amount of ions that are in the water. And of course, chloride itself is an ion, a dissolved ion. In areas like this that have a heavy influence of road salt all around them, changes in conductivity are really driven by changes in chloride, because a lot of other ions in the water are used up as energy or maybe attached to the sediment and aren't really dissolved in the water the way that chloride is. Chloride isn't used for anything for energy, so it just stays dissolved in there, and when we see big fluctuations in conductivity, we can be pretty sure that it's chloride driving that. So that is why we collect conductivity as a proxy for chloride. It's a lot cheaper and easier to collect. We can use these loggers to get continuous measurements when you can't really do that with chloride. You have to actually grab the sample, take it back to the lab, in that, even if I were to be out here every 1 hour grabbing samples, it still doesn't get the frequency that this thing can collect. So I'm gonna clean that off. I'm actually gonna cut the string because I'm gonna take this back and download the information onto my computer after I sample, and I can retie a new string. All right, so we'll go ahead and do the water sample right away. So for this, I'm just going to take the water directly out of the stream into the syringe. One important step is to rinse everything that's going to be holding your sample water 3 times. So to do that, you just fill up your syringe and discard the water away from where you're going to be sampling again, in case there was something in the syringe that might contaminate your sample. And even though we have a lot of ice and snow here today, the water is still flowing underneath, and we've got this nice little open patch. So it's perfect for getting a good water sample. So this is the water that I am going to end up taking back to the lab to analyze, to find out what the chloride concentration is exactly, from what I just collected. So I use something called an ion chromatograph I load the vials, or load a bunch of water samples into vials, and it automatically runs and will detect the amount of chloride in each sample. I have a fairly strong background in chemistry. It wasn't my favorite subject in school or in college. I took up through organic chemistry in college, and that's kind of where I've stopped. And that seems to be sufficient for what I'm doing right now. It definitely has come back around to, play a bigger role in my life than I originally thought it would. I majored in biology. So I took, lots of basic science courses like physics, biology, chemistry, and really they all kind of relate to water quality in some way. So having that background knowledge has been really, really useful. Okay, so I affixed this filter, little filter cap on top of the syringe. With chloride, it's kind of interesting. I don't necessarily need to filter anything out to collect chloride, because chloride is dissolved in the water and it doesn't leave through filtration, and it just kind of stays dissolved in the water. So I'm really filtering out other things, so other organic little bits, or pieces of algae, or sediment that might be floating around, because that can impede with the machine's ability to detect chloride later in the lab. All right, so again, I'm gonna rinse the sample container 3 times. So there we have our nice, clean, filtered water sample that I'll be testing in the lab later on to find out exactly what the chloride concentration is. All right, so the final thing that I do in the field, I use this handheld field meter with this little probe attached to take a conductivity reading. So I know I mentioned earlier that I use this logger to continuously collect conductivity, but it's important to have a third party sort of check to make sure that the logger is actually working correctly. So that's why I take this field snapshot. It's also useful for giving us information just like right away, because sometimes I don't run these samples for a few weeks, but I might want to know right away what's happening in the stream. So I just kind of put this in and wiggle it around and let it rest. Okay, so we have 2.2 degrees Celsius, 1,609 microsiemens per centimeter of conductivity. So that is really all that I do out here, collecting chloride and conductivity and temperature, and then we will know more once I take it back and compare it to other samples that I've collected throughout the year.